Hello, in this video we're going to go through question 6 in lesson 3. So the point k4 is the same distance from 4,1 as it is from 6,1. Find the values of k. So this is the type of question I can very easily do graphically. I've graphed my point 4,1 and 6,1, and what you might have noticed is I've actually named these A and B to help with explanation. We'll call this C, and if I know that the point C is k4, that means the y value is going to be 4. So I can actually let's just put a dotted line along y equals 4. And that's going to help give me an idea of where the point k4 will sit. And to help even more is I can put a dotted line that intersects y equals 4 at a 90-degree angle and has the point 4,1 in it, has 0.61 in it. So we can see pretty easily that the point here is C, which is 5,4. Great. Okay. So now let's do some algebra. Now, what we see with this problem is that it's the same distance apart. So if we imagine connecting a line like this, if we figure out what this distance here is, and we'll call this DAC, and we'll figure out what this distance here is, and we'll call this DBC, we can set those two equal to each other and solve. And for the algebra's sake, C is equal to K4, we see that we'd have one unknown there. So what I can do pretty quickly is I can do this. I can say that the distance of AB squared is equal to the distance of BC squared. And so now we can work this out. So let's see. So we're going to have 4 minus k squared plus 1 minus 4 squared is equal to, and then we're going to get 6 minus k squared plus 1 minus 4 squared. So now we're going to, if we actually went through and simplified this, 1 minus 4 is negative 3, so negative 3 squared is 9, 1 minus 4 is negative 3 squared is 9, so really nicely those cancel out. So I end up with 4 minus k squared is equal to 6 minus k squared. And then I get all excited and I say, oh, this is perfect because I can take the square root of both sides and be left with 4 minus k is equal to 6 minus k. Awesome. So therefore, 0k is equal to 2, which then I get really frustrated and I realize this doesn't make sense. So something funny is happening here, and that's okay. So I get this situation and I say to myself, okay, well, this is a problem. Let me try this in a different technique. So what I'm going to do is I'm going to expand both of these binomials and then simplify. So to expand the binomial, we write it out twice, and often what people will learn is that when we expand binomials is they'll say, okay, we'll use the FOIL rule, first, inner, outer, last, and I really don't like the FOIL rule. And the reason why is because it's teaching you how to expand one specific case, and that is where you have two binomials. This is what you want to remember. Take everything in the first bracket, multiply it by everything in the second bracket. If you remember it that way, it doesn't matter if these are binomials, trinomials, or if they have 1,000 terms. You'll know how to actually expand those. So let's continue. So 4 times 4 is 16. 4 times minus k is minus 4k, minus 4k, because we go negative k times 4. Negative k times negative k is plus k squared. So now we do it here. So we get 36 minus 6k minus 6k plus k squared. And a question students always ask me here is, do I have to write this out every time? And the answer is no. But if you're learning how to do this, taking a moment to write an extra step is always helpful. Also, if you're trying to illustrate your understanding, that extra step is nice. So if I keep going now, what happens are these k squareds get canceled out. Oh, I made a sign error here, I see. Let me just fix that. I won't restart the video because I've already done that about 5 or 6 times. So if I rearrange this, I'm going to get 4k is equal to 20, and k is equal to 5, which is awesome because that's my answer. But that still begs the question, why is it if I apply the square root to both sides here and I I get the wrong answer, but here if I expand, I get the right answer. And it actually has to do with the fact that if I take the square root of both sides here, what I'm doing is I'm removing that idea that the order of the two x values doesn't matter because I'm removing the square root. Remember, by squaring this binomial here, that is what's actually removing the direction of the movement, or what we say is displacement. So it kind of brings us back for a second to our formula for distance of a line segment. And the distance of a line segment is often given to students as follows. It's that d squared is equal to, and often say x1 minus x2 squared plus y1 minus y2 squared. And what students quickly learn is that it actually doesn't matter what order you put in your x and y points, because though this will affect the sign inside of the brackets, when we square it, it becomes positive. And this kind of brings us to a wonderful connection to physics, and a word that often causes students problems in physics is displacement. Oops, pardon me. And we think of displacement versus distance. Displacement has direction. Distance has no direction. So let me give you an example of what I mean. If I'm away from someone, I might say to them, I'm 2 kilometers away. I'm giving my distance. But if I say to you, I am 2 kilometers east, I'm giving you my displacement. And on the Cartesian plane, positive and negative represent direction. Represent direction. So if we want our displacement, we need to make sure that we put the points in the correct order in order to get the direction that we're traveling. So if we take a look at this diagram up here, if I'm a little more careful in how I select my points, this question will actually work out. And what I mean by that is I'm going to select my points for my formula such that I get the direction correct. So that means I'm going to take the rightmost point subtracted from the leftmost point, and then whether it's going from bottom to top or top to bottom. So let me show you what I mean. If we take this point, A is 4, 1, and C is K4. Well, I can see that I'm traveling in the positive direction, so that means K is going to be larger than the AX. So I'm going to write this as K minus 4 squared, and then I can see that I'm going from the bottom up. So what I'm going to do now is I'm going to select, I want to figure out my displacement in the y direction, so I'm going to say plus 4 minus 1 squared. Now again, this is a little funny because I haven't actually paired up the coordinates right, x1, y1, x2, y2, but what I've done is I've actually made sure the displacement inside these brackets are correct. So now if I come up here, and let's do that for the other one. So now I'm going to say 6 minus k. So this is going to be 6 minus k squared. And then I'm going to have, now I want to make sure that this is traveling downwards, and I see that 4 is above it, so I'm going to have 4 minus 1 here. Oh, sorry, I'm going to have plus 1 minus 4, because if it's traveling downward in the y direction, I should end up with a negative value, which makes sense. And so now again, I can apply some algebra here. We see very quickly that those cancel out, and then what I end up with is k minus 4 squared is equal to 6 minus k squared. And now I'm going to take the square root of both sides, but the wonderful thing here is because I was aware of the displacement and making sure the direction was correct, I'm going to end up with k minus 4 is equal to 6 minus k. So then when I rearrange this, I get 2k is equal to 10, and k is equal to 5. And then that is the right answer. So there's a really interesting and subtle idea in this problem. So like I said, even though it's easy to do graphically, and it's pretty easy to do algebraically, provided you remember to expand the brackets here, because by expanding the brackets, you remove the need to account for the direction of your points here, you'll get the right answer. However, it brings up a subtle point when you're actually calculating the distance formula, in that the value inside each bracket is actually the displacement. This is the displacement. So in this question, if we don't actually if we want to get to this step here and take the square root, the displacement actually has to be correct, meaning the direction has to actually be accounted for. Otherwise, you're going to get this odd canceling out effect, and thereby not getting an answer. So again, very subtle point that often doesn't play a big role in our questions, but interesting nonetheless. I hope this helped.